In this video, we are going to explore how to do synthetic division and why it works. But first we need to go over some rules. First of all, synthetic division only works when you are dividing a polynomial by a linear factor, such as x plus 2 or x minus 3. Second, you must always check the descending order of the exponent of the variable. If any term is left out, you must add it with 0 as the coefficient. For example, x cubed minus 1 becomes x cubed plus 0x squared plus 0x minus 1. If you leave terms out, the division will not work. To test this, try dividing x cubed minus 1 by x plus 1 using long division without adding the missing terms. You'll find that it doesn't work so well. Now, let's see an example of synthetic division at work. Let's divide the polynomial y equals x to the fourth minus 3x cubed plus x squared minus 5x plus 9 by x plus 3. First, we must change x plus 3 into a number we can divide by, so we set x plus 3 equal to 0 and solve for x to get negative 3. Negative 3 then moves to a box in the top left corner of the area we will be working with. Then we take only the coefficients of the terms and bring them down beside the negative 3 to set up our workspace. Do not forget to bring down any negatives as well, or you will get the wrong answer. Now we're ready to start. First, you bring the first number down to the bottom. Then, you multiply it by the number in the box, negative 3, and move that product to beneath the second term as shown. Now we'll do an old school vertical addition of the two numbers to get negative 6. Again, we multiply the number by the box number and move it up. Add the terms together, multiply the box number to get negative 57, add to get negative 62, multiply to get 186, and do the final addition to get 195. You always want to box off the last number, and I'll show you why in a minute. So now we have another list of numbers, but what do they mean? Well, we can make a new polynomial out of them like so. First, you take the number left of the box number, and this becomes your constant. Then you move to the number to the left and multiply it by the first power of x, in this case to get 19x. Move to the next number and multiply by the second power of x, so we are subtracting 6x squared. Move again to the next number, our final, and multiply by the third power of x, so we are adding 1x cubed. But because this is our leading term, we don't need a plus sign. For larger polynomials, you can continue by multiplying by consecutively larger values of x until you run out of terms. But what about our box number? This number is our remainder. Some polynomials will divide evenly, and in this case, you will get a remainder of 0. Our remainder of 195 will be divided by x plus 3, what we originally divided by, and added to the end of our polynomial to get our answer. To prove that this works, if we use long division, we will see that we get the same answer using both methods.